Chapter 6, Section 6.1. I put a copy of this document on Canvas already, and so I want to go over these problems. First is find the domain of rational functions. Okay, so let's talk about domain a little bit. We have, let's say you have this equation, y equal x minus 2, and let's put another equation next to it, which is y equal 1 over x minus 2. Okay, so these are two separate problems. Now, if I want to graph any equations, I need to draw a table. I need to come up with some value for x, arbitrary numbers, and substitute here to find the y value, right? And let's do it at the same times. So again, x can be any number. Let's say x equal to, I don't know, like 0. When you substitute 0 here, then y is 0 minus 2, or y is negative 2. We'll say x equal to 1. You substitute 1 here, 1 negative 2 is negative 1. And when you substitute x equal to 2 minus 2 give you 0. And you could also some negative numbers if you want. Let's say I put negative 3 here. Negative 3, negative 2 is negative 5. So for any number, whether it's 0, positive, or negative number, you always have a y value. So domain is x. So we just say domain is all real numbers, all near numbers, whether it's 0, positive, negative, any number you substitute for x, you always have the y value. So since domain is all real number and y is always depend on this, so that means y, which is the range is the y. Range is also all real numbers, because y depend on the x value. Now let's look at this equation here. If I substitute 0 for y, for x, then it's minus half or minus 0.5. So you have a value, that's fine. If I substitute 1 here, then it's 1 over 1 minus 2 is the negative 1. So you do have a value. But when I substitute 2, for x, see what happens. What is 1 over 0? When I use my calculator, 1 over 0, the calculator give me error. Means anytime you take a number and divide by 0, it's undefined. And you could always verify that by using your calculator. So there is one number. There is one number that when you substitute for x, it doesn't give you any y value. So in this case, do I claim that domain, which is the x, is all real numbers? No. It's all numbers except 2, except this number. So you could just say domain is all numbers except 2, or just say, you know what, x cannot be 2. And this is a symbol we use, not equal. So this is a rational function because it does have an x at the bottom, right? So what's the difference again between these two? Because there is an x at the denominator that create exceptions. So if that's the case, if I have equation like this, y equal like 3 over x plus 5. What is the domain? Again, you could substitute any numbers except what? What number would make the denominator 0? What number would make the denominator 0? Isn't this negative 5? So that means if you substitute negative 5, then it's undefined. There is no value for that. So we just say domain is x cannot be negative 5. So how do I find that negative 5? What you need to do is always take the denominator and set it equal to 0 and solve it. That gives you the number. See? X equal negative 5 is a number that must be excluded. So what if I have something like this? Y equal x plus 1 and x minus 7. We don't care if you have an x at the top, it's just the bottom. What number would make this 0? 7, right? So you take that and you set it equal to 0. You say, you know what? Do not substitute 7, because if you substitute 7 for x, this is what's going to happen. 8 over 0, which is undefined. So domain is all the numbers except that one. So for any fraction that has a variable at the denominator, if he asks you to find the domain, take the denominator, set it equal 0 to find that number that must be excluded. See here, we don't have any x at the denominator. As a matter of fact, what you could do, you could write this as y equal 2/3 of x minus 7 over 3. This function doesn't even have a denominator if you write it like this. So what is the domain? All real numbers. B, all real numbers. All right, so this one, you have to take the denominator and equal to 0, right? So you just say, I'll take 4t, set it equal to 0, divide both sides by 4. T is 0 divided by 4. If there is a fraction that has a 0 at the top and the number, you could use a calculator. 0 divided by 4 is 0. That means you could substitute any number for t except 0. So domain is all real number, and t cannot be 0. Means do not substitute 0 here. When you substitute 0, what happened here? Look, what is s of 0? 0 to power of 2 is 0 plus 9 over 0, which is 9 over 0, which is undefined. Any number over 0 is undefined. All right. How do I find the domain? There is the x at the bottom, right? Remember, what we do is we take the denominator and set it equal to 0. You're allowed to substitute any number except 10. So x is a real number and cannot be 10. X cannot be 10. So that's how to find the domain. Well, how do I find the domain for this one? Okay, so take the denominator and set it equal to 0. do this problem here for you. Take the denominator, set it equal to 0. So solve this equation for x. The first method of factoring is you factor x out. What is left is this. And then we could also factor this part. Find two numbers whose multiplication is -8, and when you subtract or add, it's -2. So you put an x in each. -4 plus 2 equal to 0. In this case, you could also, instead of x, you could write that x minus 0 if you want. So remember how we take the denominator equal to 0? This time, what numbers would make the whole thing 0? Take each parenthesis and set it equal to 0. There are 3 numbers. There is 3 numbers. If you substitute any of these numbers here or at the denominator and numerator, it would make the functions undefined. So domain is all numbers except these 3. Domain is all numbers except these 3. Now, in this case, what I do is I see that I have x at the top and x on the bottom, right? So let's see, before I actually find the domain, let's see if I can simplify this. They didn't even ask for the domain. So this one, if you factor x at the top, you have 11 minus 66 x, 11 x, x and x cancel. So that means I can actually factor 11x here. Remember, do not do this. This is not correct. Do not simplify these two. So factor 11 out first. Then cancel, so that gives you this. Now, let's talk about this a little bit here. I've seen people, when they have something like this, they do this. No, this is wrong. Let's throw a number for x. Let's say you have x is 3, right? If I ask you to simplify this, isn't this 2 over 5? Okay. But what happened when you do this? Then you come up with what? -1, -3, -4, which is not correct. So if there is a plus or minus between numbers and variables, you cannot cancel it. Don't mix it up with situation like this. Look, 5x over 5. Yes, this is multiplications. In this case, you're allowed to do that. But if there is a plus or minus between, do not cancel. This is like the whole thing is like one item. You cannot break it. Okay. Number 6, 7 and 21, they both have 7 in common, so I factor that. 9 and 27. 7/9. Now we are using method of factoring now. Why? Because you want to use that and simplify. You know, before I go over these problems, let's think of this. Let's say you have 7 minus 3 and 3 minus 7. Let's look at these fractions. 3, 3, 7, 7. It just, if you have a positive 7, opposite of negative 7, you have negative 3 is 3. On the top, I have 4. At the bottom, I have negative 4. So the only difference between these two is negative. The answer is negative 1, right? So that means when you see a situation like this, you could change 3 minus 7 to negative 1 times 7 minus 3. Why? Because look, when I distribute this, what is minus 1 times negative 3? 3. What is negative 1 times 7? Negative 7. It's the same thing, but when you write it like this, then you could see that, right? Or what you could do, you could take this and write the other one, as long as you put a negative 1 behind it. Why? Because look, negative 1 times negative 7 is 7. Negative 1 times 3 is negative 3. Okay, it's negative 1. So in that case, if I have A minus B and B minus A, look, positive B, negative B, positive A, negative A, you could always take one of these two. It doesn't matter which one, write the other one and put the negative 1 behind it. And the outcome is always negative 1. Okay? So if that's the case, then here, negative 3, positive 3, negative x, positive x. So you could take one of this, write the other one if you want, and the outcome is negative 1. All right. So number 8. Now, from now on, I'll put the solution for you for some of these problems. So for number 8, we want to simplify, again, rational expression. Why we call it rational expression? Because there is a variable at the bottom of the denominator. Remember this method of factoring that if the number before x2 is not 1, then I'll show you how to do the factoring here. You need to find two numbers whose multiplication is negative 36, and when you subtract is negative 16. And how do I find those numbers? You don't have to guess. Remember, you just use your calculator to keep dividing by 1, 2, 3, 2. When I use my calculator and divide by 1, 36 and 1, now the difference is not even close to 16. But when I take 36 and divide by 2 is 18. These two numbers are the good numbers. Why? Because when you multiply, it gives you negative 36, and when you subtract, it gives you negative 16, minus 18 and positive 2. So instead of negative 16x, I write minus 18x plus 2x. Why I'm doing that? Because what I did, I changed the trinomial. Trinomial means when you have 3 terms. I changed the trinomial to 4 terms, which I can use group factoring. Group factoring is when there are 4 terms, right? So instead of minus 16x, I write minus 18x plus 2x. Now, if I split this into 2 different groups, the first one, I remove 3x is x minus 6. And if you recall, for group factoring, you don't have to worry about factoring the second part because this parenthesis must be identical to this. So when you find this parenthesis, put that and leave it here. And then what number times x is positive 2x? Positive 2. So that would be factorization of the numerator. Now the bottom one is a trinomial which doesn't have any number but 1 here. So in that case, you put an x on each. 2 numbers whose multiplication is positive 12, and when you add algebraically is minus 8 is this 2. So remember, there are 2 types of trinomial when we do factoring. There is one that doesn't have any number here is 1. So in that case, you always put x and x. And there is the one that does have a number but 1. So in that case, you got to do this method. These 2 cancel, so that would be your numbers. Number 9, the top one, again, I'll show you here. Here. You take, this is a trinomial, that number in front of x2 is not 1 anymore. So you take the first and the last number and multiply is -9, and the middle term is minus 8. Find 2 numbers whose multiplication is -9, and when you subtract is -8. Those are -9 and positive 1. So instead of writing minus 8x, you write minus 9x plus 1x, because minus 9x plus 1x give you minus 8x. Is the group factoring? You find this, you put that x minus 3 here. So then you take that one and you put it here. The bottom one is group factoring. How do I know? Because there are 4 terms. I'll show you here. These 2 cancel, that would be the answer. And again, the best thing is to have a copy of this in front of you while you're watching the video so you understand the process. What I did here was the top one, they both have 8 in common. 24 and 32, they both have 8. So pull that out. And these 2, one is 4x minus 3, one is 3 minus 4x. Remember I said the only difference between these 2, when you have, look, you have 4x minus 3, and you have 3 minus 4x. Look, minus 3, positive 3, positive 4x minus 4x. The only difference is -1. Means you could take one of them and write the other one, as long as you put the -1 and this cancel. That's why here, I'll change this one to 3 minus 4x and I put a negative here. These 2 cancel, 7 goes to 14, so you got minus 6. The first method, they both have 15. They both have 4. Now here, this one, 3x2 minus 3. First, I remove x. And instead of 1, you could write 1 to power of 2. Now, remember, there is a factoring formula that if you have difference of 2 perfect square, it's conjugate, means is addition and subtraction, or addition, summation and difference of these 2. So in that case, x2 minus 1, 2 is x minus 1 times x plus 1. That's why they put that one here. Then you start canceling. X plus 1 from the numerator and denominator, 1 cancel. 1 is left. X plus 5 cancel. 3 goes to 15, so that would be the outcome. And remember, you could always pause the video and copy solution of the problem. The first one is the group factoring. I'll show you how to do it here. How do I factor this? That's how to do it. How do I factor 9 squared minus 9b? First, you remove 9, and then remember this formula? So you do the factoring for all, and you put it back here. And then you start canceling a2 plus a2 1, a2 plus 1, a2 plus 1, a plus b, and that's the outcome. Now, when it comes to divisions, remember, let's say you want to divide this. 3 over 5 divided by 9 over 10. How do I divide two fractions? Anytime you want to divide two fractions, you don't touch the first one, but you change the division sign to multiplication, which is the dot here, and reverse the second fractions. So before you simplify, always change the division sign to multiplications and reverse the second fraction. That's the important part. Reverse the second fractions. Okay? That's what we did here. So here there was a division sign, right? I change it to multiplication and reversing the second fractions. So 5x plus 10 now is at the top. Then you just factor the first method and simplify. Same thing here, look. Change the division sign to multiplication by inversing the second fractions. And x2 minus 81 isn't x2 minus 81, it's these are trinomial. Two numbers whose multiplication is 81, and when you add algebraic is minus 18. Two numbers whose multiplication is 36, and when you subtract is negative 5, and then you simplify. Change division to multiplication, reversing. These two cancel. Remember this one. Look, 3 minus x and x minus 3. Remember, the only difference is a negative 1. You could take these and write the other ones as long as you put a negative here. This is not division anymore, it's multiplication, so you don't have to reverse the second fractions. And x2 minus 9 again is conjugate, it's x2 minus 9 is x2 minus 3 to power of 2, which is, see, this method of factoring, which is a2 minus b2, we use it often. Remember this one? Is a minus b times a plus b. Now, what is this formula? There are two formulas that is the last method of factoring, if you recall. One was a cubed minus b cubed. If you have a difference of 2 cubed is a minus b A2 plus AB plus B2. If this is a negative, the first parenthesis is negative, the rest is all positive. And you also have the sum of 2 cubed is that so these are two formula if you have the difference or sum of 2 cubed. So the top one is this. Okay. So this two cancels that. Now this problem's, ooh, this is a long, long problem. You have to do all these factoring. Look. It's a very long one. That has combination of basically most of the methods of factoring is all applied to these problems. How do you take the trinomial, change it to group factoring, trinomial. These are all the trinomial that has a number before x2, see? This, the one that doesn't have any, it has a 1 is easy. But the one like these, the one that has x in front of x2 is not 1, is like 5 here, 12 here, 12 here, 3 here, then you gotta go through all this. So these 4 related to those trinomial that has a number but 1. And this problem continue on the next page, look. It's a very, very long one, but I guess if you understand this problem, that means you understand all the factorings. And then you have to cancel these. You get this one here. You change it to group factoring again. Instead of positive 3x2, I write positive 4x2 minus 1x2. So I can change it to group factoring. Now, right here, what is 4x2 minus 1? It's 4x2 minus 1, 2, which is, you could write it as 2 to power of 2, 2 to power of 2, x to power of 2, 1 to power of 2, and then that would give you this. And I'll show you x4 minus 1, 4 is this, and then you could break this one too also. These problems, they're saying that if you have a function of g of x is this, what is g of? G of 3 means take the 3 and substitute for the x here. What does g of negative 1 means? Take negative 1 and substitute for the x. So let's say instead of g of x, I just say these functions, y equal x2 plus x over x3 minus 25x, right? And then they ask you to substitute 3, negative 1, and 2. It's very similar. Instead of g of x, let's say is y. When we ask you to find g of 3 means when x is 3, what's the value of y? What would you do? Don't you take these 3 and substitute for the x here? Or when we ask you to, when x is negative 1, how do you find the y value? You take the negative 1 and substitute here to find the y, okay? So in that case, when x is 3, then this is your y value. When x is negative 1, this is your y value. So it's like here, 3 over 8, 17 over minus 48, and last one is minus 2 over 7. So it's very similar. G of something means when x is 3, find the y value. Okay, so that would be end of section 6.1.